All right, here we are for our first learning target, which says I can use key features to graph a quadratic. This is from section 2.2 in the book if you need some more reference. And I wanted to start first with just the big picture. So when we see a quadratic, what have we seen in the past? We see some key features. We see an axis of symmetry that cuts our parabola in half. We see that there is a vertex. That vertex is either the minimum or the maximum, depending really on your A value. That A, that number out in front of your quadratic, is what's going to determine whether it is right side up, if it's positive, or upside down if it is negative. So that's our big picture. So now we want to get down to the nitty gritty, and we're going to focus on two forms of a quadratic. The first form is vertex form. You can see our vertex form is here, and then we'll take a look at what if it is in standard form. So vertex form, f of x equals a times the quantity x minus h squared plus k. Okay, that is vertex form of a quadratic. And we're going to see at step 2 here why we care about vertex form. We care because it gives us the vertex, the h and the k. So as we graph quadratics, and as I ask you to graph them in this chapter, we're going to be looking at the key features. So we're going to take a much more in-depth look than we did in the last chapter where we were just looking at transformations. Now I want to know what is special about a quadratic. So the first thing I want to know is, does that open up or down? And I look at the A value. So A is still the number out front. If there's not a number there, it's a positive 1. If there is just a negative out front, then it's that negative. So if the A is positive, it's going to open up. If it's negative, it's going to open down, just like we saw on the last slide. Then we get to finding the vertex for a parabola. The vertex is that key point, right? Either the minimum or the maximum. And when it's in vertex form, I can just look at the h and the k. Now you have to be careful because in the formula, there is a built-in negative, right? Built-in negative says switch the sign of what you see here, and that is your h value. When we talk about our axis of symmetry, that imaginary line that cuts it in half, you don't have to draw it, but I want you to know that it's there. And your equation for your axis of symmetry is simply an x equals h, where h is the x coordinate of your vertex. Then steps 4 and 5, we will find for the other graphs that we do in this unit as well. So really want to think hard about finding x-intercepts. X-intercepts are when we're solving, our function is equal to 0, right? If we're on the x-axis, our x-intercepts, that's when the y is 0. So we set it equal to 0 and we solve. This usually takes some effort. We're really solving the equation. In the last chapter, any time that we solved an equation, we were really finding the x-intercepts. And then for our y-intercept, where did it hit the y-axis? That is when x is 0. So it says compute f of 0, which is the same as setting x equal to 0. Then it says here, plot the vertex, the intercepts if you need additional points. Sometimes you won't have enough. You still need at least 3 points to be able to feel confident about your graph. So let's go ahead and try one together. So we can see this equation, f of x equals negative 2 times the quantity x minus 3 squared plus 8. So the first thing I want to do is I want to decide if this parabola opens up or down. I look at that negative out front and I can tell that this is going to open down. So already I have a picture in my mind of a parabola looking like that. Next step, I find my vertex. Vertex is very friendly in this form, right? We see my 3 and we see my 8. Notice built-in negative there, okay? Built-in negative means that I take the opposite of what I see. Just like with our transformations, remember we always did the opposite? Same thing here. So I take the 3, I take the 8, and my vertex is 3, 8. My axis of symmetry. Okay, that imaginary line that cuts my parabola so nice and evenly where I can reflect points is just x equals 3, that same x coordinate. And then I come to step 4, which are my x-intercepts. All right, x-intercepts, I'm going to do in purple here. X-intercepts are when I set the whole equation equal to 0. 0 equals negative 2 times x minus 3 squared plus 8. When you are in vertex form, it is like someone did completing the square for you. So I'm going to subtract over my 8. I'm going to divide by -2. I get 4 equals x minus 3 squared. And then I square root. I remember that when I square root, I need the positive and the negative option. Okay, I add the 3 over. I get x equals 3 plus or minus 2. 3 plus 2 is 5. 3 minus 2 is 1. So up here, I'm going to put my x-intercepts are 5, 0, and 1, 0. I want you to list these as ordered pairs. So there they are. And then the last thing to find is my y-intercept. My y-intercept is when x equals 0. So I go to my original equation and I plug in 0 for my x. I get -2 times -3 squared plus 8. I have -2 times +9 plus 8. -18 and 8 gives me -10. So my y-intercept, again, I'm going to write as an ordered pair, is 0, -10. All right, so now I found all of my key information. Think about how much more I have about this graph than just doing the transformations. I know the zeros, right? I know the actual solutions to the equation. I know the high point here or the low point if it was inverted. So I graph this. I have the point 3, 8 is my vertex. You don't have to draw the axis of symmetry, but if you want to, here it is. You have to write it, but you don't have to draw it. Then my x-intercepts are 5, 0, and 1, 0. My y-intercept is -10. Now we know with this axis of symmetry, we can also reflect across, right? And I could have a -10 at 6, -10. And then, this is the hard part on my tablet, I can connect my parabola. When you do this too, domain and range, my domain is -infinity to infinity because that's what I can plug in. My range is anywhere -infinity up to a +8 and including. So when you do this, this is the work that I expect to see from you. So you have to list all 5 things, but you need to show when you're finding the x-intercepts, you're solving the equation. So I expect you to show solving your equation. When you plug in 0, you can show this first step and write an answer, and that's fine. But you need to show what you did, okay? I really want to see your work for these. So if that is graphing with the key information, right, showing my work, but we have that nice vertex form, what happens when I don't have vertex form? Okay, and that is going to be standard form. So our second thing here with parabolas is standard form. And when we think about standard form, really, all that's different is how we find the vertex. Everything else, you do the process the same. You tell if it opens up or down from the A value. Your axis of symmetry is still right where your vertex is. Your x-intercepts are still where the equation equals 0. Your y-intercepts, you still plug 0 in for x. But your vertex is key. And this you learned about, but a good reminder. This is an important formula to know because it's the vertex, but it's also how you find the maximum of a function that's quadratic. So -b over 2a is your formula for that. Okay, -b over 2a will give you the x coordinate of your vertex, and then you plug that back into the original equation to find the, that's a typo, the y value. That's not a typo. Plug in the x value to find y. Okay, so that's the only difference. So what I want you to do, because again, you have done these before, what I want you to do is to take a few minutes. I want you to write this problem down. I want you to find all 5 things. I want you to graph it. And then I want you to come back on the video and check your work. So go ahead and write this down, then pause the video. All right. So hopefully this is what you got. So we look at this. I could tell that it opens up because it's positive. I go to find the vertex. I'm doing negative b over 2a. Negative 4 over 2 times 1 gave me negative 2. I need to plug that negative 2 back in, and I get negative 5. Be careful there. The vertex is your most important point, so you want to be really careful with that one, okay? Now I know my vertex, so I know my axis of symmetry. My axis of symmetry is x equals negative 2. Next up, I want to find my x-intercepts. To find the x-intercepts, I'm setting the whole equation equal to 0. Here, you could choose to do two things. Maybe you liked that completing the square business. I find that people usually don't. But you have to do quadratic formula. This does not factor. So I get negative 4 plus or minus 2 root 5, which is negative 2 plus or minus root 5. All right, so here's what I'm thinking when I graph those points. Root 5 is a little more than 2. Root 5 is a little more than 2, okay? Because the square root of 4 is 2. So I have negative 2 plus a little more than 2 is just a little bit over 0. And negative 2 minus a little more than 2 is negative 4 point a little bit. Okay, so that's where you can see my x-intercepts there. And then my y-intercept, I plug in my 0 and I get 0, negative 1. Again, notice I'm showing my work. I'm listing my intercepts as ordered pairs. And then I plot everything. I know it's going to open up. I know my vertex is negative 2, negative 5. Axis of symmetry is there. You don't have to draw it. Our x-intercepts, we just talked about estimating. My y-intercept is negative 1, so I can also reflect over and get that nice clear point. Okay, my domain here. Domain is negative infinity to infinity. That's true for parabolas. And then the range, we're starting at negative 5 included, and we're going up to infinity. So hopefully that's what you have. Check in with me if it's not.